Hi, this is Synthchaser from synthchaser.com. In our last video we had a look around inside this Rhodes Chroma and we got it up and running and making sound by making a couple of temporary repairs to the power supply. Today we're going to install a proper fix and continue the restoration and repair. Unless there's a lot of problems that we need to repair, we should be able to get this working 100% in this video. In our last video we found that the Chroma wasn't working because its 5-volt digital supply was sitting at 2 volts. The first thing I found was this shorted high-power Zener diode that sits across the main filter capacitor here. When I removed it, I was getting 5 volts on the digital supply without any load. But when I connected the load, again, the 5-volt supply dropped to 4 volts, which was too low to run the synth. We wound up finding that the main filter capacitor, this huge 47,000 microfarad capacitor, had failed with a high ESR. At first I was considering putting in one of these switching power supplies. It seems many people have installed them in their Chromas with success, but the thing that I don't like about the design is that there's no linear post-regulation, so the switching supply is hooked up directly to the synth's plus and minus 12 volt analog power rails, and those are used by the audio path. I could see using a switching power supply for the power-hungry 5-volt digital rail, but it doesn't seem beneficial for the analog rails to use a switching supply. Maybe down the road I'll make my own switching supply that addresses my perceived deficiencies with this current one. So that left me with the task of repairing the parts that had failed on the original power supply. I looked for this 50-watt Zener diode and came up empty. They're still produced, but they're not stocked by anyone, and they're super expensive. Even if I didn't have to buy 200 of them, 48 bucks each is ridiculous. And you can't just take a bunch of lower wattage Zener diodes and put them in parallel, because their Zener voltages will all have some tiny difference, and the current will mostly get dumped through the one with the lowest Zener voltage, which would fry them all very quickly, although one by one. So I looked at the schematic again, and it occurred to me why the Zener diode was there in the first place. The service manual says it's there to reduce heat dissipation on the rest of the circuitry, but I didn't notice any heat problem when I had it removed. It looks like the real reason that Zener diode is there was as an afterthought, because they found that they could be slightly exceeding the wimpy 7.5 volt voltage rating of the big filter capacitor. So this Zener diode was kludged on top of the capacitor to keep the voltage across the capacitor no greater than 7.3 volts. Well, even at 7.3 volts, running a filter capacitor so close to its rated voltage is going to shorten the lifespan of the capacitor so much, it's no wonder that this capacitor's failed. So rather than blindly following the original schematic and putting back a 7.5 volt capacitor, or as close to it as possible, and tracking down one of those obsolete Zener diodes, we're going to fix this the proper way, with a much better filter capacitor. The original capacitor is at 7.5 volts, has a 7.5 volt rating, and we're going to replace it with a 25 volt capacitor. The original capacitor was rated to 85 degrees Celsius, and our replacement is going to be rated to 105 degrees Celsius. By replacing the filter capacitor with a better spec'd one, not only can we safely eliminate the Zener diode, but our capacitor will last a lot longer. This one capacitor actually cost more than this whole switching power supply, but I think it's the right way to go. So we're going to put this in now, and we're also going to take out the power supply to change the other electrolytic capacitors and replace a trimmer that we noticed was missing in the last video. We're also going to pull out the other circuit boards as well and recap the electrolytic capacitors. I have a kit for this available on my website, synthchaser.com. I've looked at how each capacitor being replaced gets used in the circuit, and all the capacitors in the audio path get replaced with audio-grade capacitors. The power supply comes out with the back panel here, so to get it out I've moved the synthesizer over the edge of my workbench, and I'll be removing 10 screws from the bottom, which you can see are the light silver-colored screws. So while I've got the voice cards out, besides just recapping them, I'm going to be checking each of the Temco resistors to make sure that they're okay, since from time to time I do encounter bad ones. And there are 4 Temcos on each voice card, one for each of the 2 oscillators and one for each of the 2 filters. And they are these little black resistors here that are seated thermally coupled onto these chips. ARP synthesizers use a 1.87K Temco, and a Temco is a special resistor. This one measures 1.87 kiloohms at room temperature, which is 25 degrees Celsius. And the resistance of the Temco increases by 3.3% per degree Celsius to provide temperature compensation for the exponential converter portions of these circuits. So let's take a measure of the Temco here. And this one is measuring a bit low at 1.748 kiloohms. And that's actually okay because it's very cold here in my workshop. In fact, you can figure out the exact temperature of my lab with the information I just gave you. So let's see who's a brainiac and can figure it out correctly and post in the comments down below what the exact temperature of my lab is now. So now I'll go through and I'll check each of these Temcos and I'll recap the voice cards. For the most part, this was no trouble, with the exception of these 3 capacitors here on this one voice card, where either the little rubber bushing on the capacitor disintegrated or it leaked or something like that, but there was this black stuff here on the pads, which made it a little more difficult to desolder, but we'll clean that up and get it ready for the new capacitors. And this all came off those 3 capacitors there, but it's clean now, so solder will flow there when we solder our new capacitors. For the voice card motherboard, since there's some wires soldered in place here, what we're going to do is we're going to remove the screws and we're going to lift the board up and work on it inside the synthesizer. On the CPU board, I'm going to be removing the corroded battery holder and cleaning up the damage. The battery holder itself is very corroded, but there's also a little bit of battery corrosion down here on the circuit board. I'm not going to install a new battery or a battery holder because I'm going to be changing this board out for the MIDI upgrade. Since this board seems to be in good working condition, I do want to test it and clean it up since the board on my next Chroma may not be so nice. Also, I'd like to get the Chroma working 100% before I make any modifications like adding the MIDI to keep variables to a minimum in case I need to troubleshoot something. And this looks like a good place to wrap up this video. In the next video, I'll show you some of the upgrades I made to this Chroma, and we'll hear some of the amazing sounds this instrument is capable of. Until then, this has been Synthchaser from synthchaser.com. Thanks for watching, and have a great day.